So this is just another view of a galvanic cell with zinc and copper. Instead of the U-tube that you saw in the last example, there's a porous disc that allows the sulfate ions to go through in order to keep the charge neutral on both sides. Okay. Again, as the electrons are being transferred from the anode to the cathode, so from the zinc to the copper, zinc ions are going into solution and making that solution more concentrated in zinc ions, and the copper ions are gaining those two electrons and coming out of solution, thus making the copper ion concentration in solution less concentrated. Here in slide 16, as we go through it, you can see up here in the upper right-hand corner, this is another show of that same exact cell, zinc and copper. There's your U-tube that has your salt bridge that are keeping the ions and each side neutral. You can see the voltage reading across that cell, 1.10 volts. We're going to get to very soon how you actually calculate that. But that difference in electrical potential between the anode and cathode, as you can see, is called, there's three different names for it. It's all basically the same thing. I usually use cell voltage, but you can see it written as electromotive force or cell potential. All of these things are that difference in that potential of changing chemical energy into electrical energy. Couple things about the cell. Here's our spontaneous reaction. The zinc is going from zinc solid to zinc ions. It's going from a 0 to a +2 in terms of oxidation state. The copper is going from a +2 to a 0. So in terms of its oxidation state, it is decreasing in oxidation. So it's actually undergoing reduction. So that is your spontaneous thermochemically favored reaction written for that cell diagram. One thing to note for a standard cell, and that's always how we're going to talk about these until we get to the Nernst equation, is that the solutions to start, so this zinc solution that's right here when the cell is set up, and the copper solution right here are both 1 molar. Now this next thing here is very important, and this is how you write and show a cell. It's called line notation. The anode is always on the left-hand side. The cathode is always on the right-hand side. It always goes in this order. You have your anode metal, okay, as you can see they're listed as a solid. Then you have your anode solution, 1 molar to start. You have your zinc ions. Then you have these two lines right here, and this kind of represents the salt bridge, or the difference between the two sides of the cell. Then you have your cathode solution, in this case copper 2 at 1 molar, and you have your copper metal, or your cathode metal that you are dealing with. So this is line notation. You'll see it written a lot. Again, anode metal, anode solution, then your double line that represents your salt bridge, your cathode solution, and your cathode metal.